Hey, it's Mr. K, Chemistry 30, Unit D review. We're talking about pH curves. The graph of the student's titration data shows the titration of a blank acid with a strong base on the graph. Buffering occurs at blank. Oh, this question drives me nuts. Okay. Now, essentially, buffering is going on here. You have your acid, you finish off as a base, you're adding your base to your acid, it's just getting more basic. Now here, buffering is taking place. Basically, what's going on is you are creating an equilibrium. And at this time, the concentration of the weak acid is equal to the concentration of its conjugate weak base. So whatever you're adding to this thing, you're just shifting between weak acid and conjugate base and water, really. So nothing is going on here except to say that the pH is staying the same and we're slowly using up our acid, getting closer to the point where it's going to jump, use up all the acid, and essentially spoil that buffering system. Okay, so buffering occurs at region 2. Now I'm going to make a special mention of this because there's a typo in your textbook. This is not buffering. There's a point in the textbook that says it is. It's not. This is the end of the reaction. If you were to have a polyprotic, however, you would have buffering here, and no buffering at that final step. Okay, this is my first step, my second step, and at the end, I've simply completed the transition. So let's go through, please. Okay, a couple things here. First of all, I've covered the second question first. Region 2 only is where buffering occurs, and it's asking strong or weak acid. For that question, we can look at the equilibrium point, which is right about here. And because we see that that equilibrium point is just greater than 7, it means that it's shifted more toward the strong base and less toward what must have been a weak acid. So with that in mind, we have a weak acid and buffering at region 2. All right, thanks a lot for tuning in.